Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class I will teach you some important problems on the chapter friction. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the Iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Two problems are given. First, I discuss this problem. Find the acceleration A1, A2, A3 of the three blocks if a horizontal force 10 Newton is applied on 2 kg, 3 kg and 7 kg. That is, three blocks are placed one upon other. Coefficient friction between every block is given this, and thus this surface is smooth. This surface mu equal to 0 means this surface is smooth. Now find the acceleration of A1, A2, A3. Now here total 9 answer will be this. First, 10 Newton force is applied on 2 kg. So here you have to draw the free body diagram. Acceleration A1, A2, A3. Here you have to draw the free body diagram on each surface. Then you can solve the problem. Now let's start. Now first we consider the 10 Newton force act on the 2 kg block. So what if we draw the free body diagram? Then 2 kg, 3 kg and 7 kg. Now 2 kg 10 Newton force is act on 2 kg block. First 10 Newton act on 2 kg block. So I have told in my video of friction chapter block on block that when a force act on the block, then that is the block will move fast on which the force is applied. So among three blocks 10 Newton acts on 2 kg block. So 2 kg block first move. Now if the block moves in this direction, what is the friction force act? Friction force act in this direction. So this is in this direction, friction force act. This. Now this is friction. So friction force act. This is action. So this is reaction. This is reaction. Now this is opposing force and this will be the driving force. Now if the this is driving force, then this for this driving force 3 kg tends to move over the 7 kg, but friction acts in the opposite direction. So this is the opposing force. Now for this, if this is action, then this is reaction, this is reaction. So in this way, that is different friction force act on the surface. First 10 Newton force act in 2 kg block. So this will move. First try to move. Then this block force F1, F2, and ground is 0. So ground friction force in the ground is 0. Now what is the F1? F1 equal to mu mg. Mu, what is mu? Mu equal to 0.2. So 0.2 into mg, that is 2 into 10. That is 4 Newton. So 4 Newton force act in this direction. 4 Newton. Now 10 Newton act in this direction, 4 Newton. So what is the acceleration of this block? 10 minus 4 equal to ma, which is a1 equal to 6 by 2, that is 3 meter per second square. So this is the acceleration. Okay. Now friction force act here 4 Newton and F2 equal to what? F2 equal to, if we calculate F2 equal to mu equal to 0.3 of total. Now what is normal reaction at here? Normal reaction here will be 2 plus 3, 5 kg total, because 2 kg rest on 3 kg. So total reaction force, normal reaction will be 5 into g, that is 10, 50. So 50, that is 15 Newton. So here friction force equal to 15 Newton. Now for F1, force Newton is the driving force, but friction force act 15 Newton. So 3 kg will not move over the 7 kg. So 3 kg block cannot move over the 7 kg because opposing force is greater than this force. So now if 3 kg cannot move, then 3 and 7 cannot move. Then 3 and 7 move together because this friction is 0. Here this is smooth, so 3 cannot move over 7. So 3 and 7 behave like a whole body, and on this whole body this is driving force, this force act. So 3 and 7 move together. 3 and 7, 3, 7. Here driving force is 4 Newton. So this is 15 Newton. This force was 15 Newton, but as 15 Newton is friction force, so 3 cannot move over 7. Here friction force is 0. So 3 and 7 behaves like a whole, behaves like a single body. So here driving force is 4 Newton. Now the acceleration of 3 and 7 will be same, so A2 and A3 will be same, which is equal to force by mass. Force is 4, mass is 3 plus 7 10, that is 0.4 meter per second square. So A2 and A3 has the acceleration this. Consider the second case when 10 Newton force act on 3 kg. Now draw the free body diagram. Here 2 Newton, 3 and 7. Now 2 Newton, now 10 Newton force act on this block. So if we draw the free body diagram, then we draw the free body diagram. So 10 kg block, that is 10 Newton force act on the 3 kg. So this block moves fast. So this block moves fast in this direction. This is A2. First 10 Newton moves, 10 Newton acts on the 3 kg block. So 3 kg block moves fast. If this block moves, then the friction comes in opposite direction. So this is the friction force act on two sides. Suppose this is F1, this is F2. So what is F1? F1 equal to mu mg, which is equal to 0.2 into 2 into 10, that is 4 Newton, and here friction equal to mu 2, that is 0.3 into 2 plus 3, 5 into g, that is 50 Newton. So 2 Newton and 50 Newton force act in this direction, 2 Newton and 50 Newton act in this direction, 10 Newton act on this direction. So as applied force 10 Newton but opposing force 15 Newton. So 3 kg cannot move over 2 kg and 7 kg. This is 2 kg and this is 7 kg. So on the 2 kg block force, this is opposing force. So this will be the driving force. This will be the 4 Newton and 15 Newton act in this direction. So 15 Newton act in this direction. Here is no friction force. Now 3 kg block cannot move over 2 and 7 because here applied force is 10 Newton but opposing force is 15 Newton. So 3 cannot move. If the 3 cannot move, then 2 and 7, 3 is raised. So 2 kg block cannot move separately, 7 kg block cannot separate. If this is raised, think practically, if this is raised, then how can this and this will move? So here 2, 3, 7 acts like a whole, like a single body. So 2, 3, 7 kg block will move together. 2 kg here, 2 kg, 3 kg and 7 kg. 2, 3, 7, 10 Newton force act. 3 kg cannot move. So 2, 3, 7 whole body moves with together. Whole body moves together. Now the acceleration of 3 body will be same. So this acceleration will be force by mass, that is 10 by 12, that is 5 by 6 meter per second square. So this is the answer for second case. If force is act on 3 kg, so this is the answer. So three blocks move with same acceleration, whose value is 5 by 6. Now third case, if the block 7, 2, 3, 7, now 10 Newton force act in this direction. So when the 10 Newton moves, 10 Newton applied on this 7 kg try to move fast. Now friction force act, friction force, this is smooth, so here no friction comes, but here friction is mu mg, that is 50 Newton. We calculate this mu mg 0.3 into m means total mass, 3 plus 2 5 into g 10, that is 15 Newton. So 15 Newton acts in this direction. Now 15 Newton, this is opposing force, so this will be the driving force 15 Newton, and if this is driving force, then this will be the opposing force, which is 4 Newton. So force act in this way, but here we can see that 15 Newton act here and 10 Newton act here. So here applied force is less than the opposing force. So 7 cannot move. 7 kg cannot move separately. 7 kg cannot move separately because friction opposes this. Now if 7 kg cannot move over 3, then 7, 3 and 2. 7 kg cannot move, so 3 kg cannot move. 3 kg cannot move, so 2 kg cannot move. Now 7, 3, 2, so behaves like a single body So 2, 3, 7. Now force is act on this direction. So here friction is more. So 7 kg move cannot move separately. Then 2, 3, 7 moves together because here friction is 0. So here applied force is 10 Newton. From ground, no opposing force here act. No opposing force act. If the ground offers a resistance force whose value is greater than 10, then the 3 blocks cannot move. But here this is smooth and 10 Newton force act. So 2, 3, 7, 3 kg, 3 blocks moves together. That is 3 blocks behaves like a single body which moves together. So now the acceleration A1, A2, A3. So 10 equal to total mass 2 plus 3 plus 7 into A, which value is 10 by 12, that is 5 by 6 meter per second square. So this is the answer. So for third case when 10 Newton act on 7 kg, so this also has the same acceleration whose value is 5 by 6. This is the answer. Look this picture. This is very important, and pseudo force, friction force and Newton's laws of motion, all force act in the same problem. So this problem is very important. So if you can solve this problem, then many problems will be solved easily. What is the problem? Here a big mass M, big block of mass M is stand on the ground. The coefficient of friction between the ground and this block is mu2, and the string is attached at the block, and which is passed over this pulley and this pulley. Now a pulley is attached also this block, and the string, the red color line is the string. So now the small block of mass M is always in contact with the block M, with the block whose mass is M. This mass is always in contact with M, and this is tied by this block is tied by the string which passes over this pulley. Now if the system is released, that is if the mass is released, then this move this way and this block moves in direction. So find the acceleration of block of mass M. What is the acceleration of this block? What is the acceleration of this block? So this is the question. Now due to this weight, this block moves down. If this block moves down, then string due to the string is constant, length of the string is constant. So if this moves downward, so the string will moves in this direction. So this will move in this direction. So this way the motion start. Now what is the acceleration? So to solve this problem, we have to draw the free body diagram of each block. Now find first acceleration of A1, A2. What is the relation between the acceleration of this block and this block? Now think that if the block moves through the distance x, suppose this block moves this distance x. Now if this block moves this distance x, then this move x direction, that is this x, that is this string moves x. So total length will descend. Total length of the string descend is x plus x 2x. X plus x 2x. So if the acceleration of block of mass M2, mass M be A, then by constant equation, as length of the string is constant, so if the block moves towards through distance x, then string opens downward is 2x. So we can say that if the acceleration of the block is A, then the acceleration of block of mass M is 2a. Then acceleration of block of mass M is 2a. So acceleration of this is A and this acceleration is 2a. Apply T dot A equal to 0. I have told in my previous video, that is video on pulley tricks, video on the constant equation and pulley tricks, I have told that T dot A equal to 0. So for the block M, what is the tension act in this direction and in this direction, T, and movement is acceleration is A. So for this block 2T, so for T and T act, so 2T to here total tension 2T A cos 0 degree, and for the block M, what is the tension act in this direction and acceleration is in this direction. So for block M, total T into A into cos 180 degree equal to 0. So T cancel 2A equal to, this is suppose acceleration A1, 2T equal to A1. So we get acceleration of the block is 2A. From this we get the acceleration of the block is 2A. T dot A equal to, apply T dot A equal to 0. So we get the acceleration of this block is double of this acceleration of block of mass A. Draw the free body diagram, capital M and small m. So here you find, here observe very carefully, observe here the students observe very carefully what are the different forces acting on each block. So draw the free body diagram, try to draw the free body diagram. First, what is the force acting on the block of mass M? Tension act in this direction, so tension act in this direction. Now this block, as the block is attached with this, so two blocks move with this in this direction, so the mass of the acceleration of the block is in this direction A. So a pseudo force, if the block moves in this direction, so pseudo force act in this direction. So due to this pseudo force act in this, so this block strike this block, so this is the suppose action. If this is action, then this is the reaction, so this is reaction R. Now so a force, a normal force act in this surface, and so friction, this block move downward, this block move downward, also move downward with an acceleration A. So friction act on the surface along this direction, which is the value of mu. What is the coefficient friction? mu1 into R, so this is the friction force. Now mg act on the body, mg act in this direction, so what is the, so this is the different force acting on the block of mass M. Now consider the what force act on the block of mass M. Here this is action, this is reaction. Now next, this is the ground, the block is present on the ground also. So now weight of the block act capital Mg. Now here a pulley is giving, pulley, through the pulley the tension T act in this direction on the pulley, and also this tension act in this direction. So this force act in this direction, this force act in this direction. Now the acceleration of the block is A along this direction. Now what is the friction force? Here friction force mu1 R, friction force act in this direction, which is equal to mu1 R. Now here also friction force act, this friction force act in this direction, which is equal to mu2 into R, suppose R2. Now what is R2? R2 is act on the surface, R2, and here ground R2 act. Now what is the R2? R2 is, so these are the different force acting on each block. I repeat once again. First, find the acceleration between this block and this block. Acceleration is, we find from T dot A, acceleration we get, if the block accelerates with acceleration A, then this block accelerates with 2A downward. Now as the block moves downward and the surface this block is always contact with this, so there is a friction act. This block move downward, so friction act upward. This is the friction force. Now if this is action, this is reaction, so mu1 to R in this direction. So mu1 R acting this is action, this is reaction, Now through this pulley a tension of this tension act in this direction and tension act in this direction through the pulley. So this is force, and weight of the block is mg act downward, and there is a friction, so friction force act in this direction because this block move this way, and normal direction from the ground is R2, this is R2. So different force act I have shown. Now position of motion of each block. First, for block of mass M, here force is R. So due to this force, the block moves in this direction with acceleration A. So R equal to M into A. This is equation 1. And and in this direction acceleration is 2a, so force mg and opposite force t minus mu1 into r equal to mass into acceleration. So this is equation 2. First r equal to m into a, and in this direction this block also moves with acceleration 2a, so mg minus f minus t, mg minus m minus t equal to m in mass into acceleration. Now r equal to ma, put here mg minus t plus mu1, r equal to ma equal to 2ma. So this is equation 2. Okay, so for block of mass m we write this equation. Now what is r2? R2 will be r2 from the along y direction, as there is no net force 0, along y direction net force 0, so here r2 act upward and downward mg minus, what is the downward force here, t and mu1 r, this will be 0. r2 minus mg minus mu1 minus t equal to 0, so we get r2 equal to mg plus t plus mu1 into r. So we get r2 equal to this, we get r2 equal to this. Now find the friction force here. So here we put r2 equal to here, we get friction force. Now summation of fx, this block moves with acceleration a, this block moves with acceleration a. What is the force? Observe that the force have not shown mistakenly. Here also a sting is attached, so here a force t is applied, sting t is applied. So when we consider the motion along x direction, when we consider the motion along x direction, what is the force? Here total force is t, and t 2t minus friction force mu2 r2 equal to this mg plus t plus mu1 r equal to m into a. So along this direction total force t friction force act in this direction, also r 2t, and now here also reaction force here present, so 2t minus mu2 into r2 minus r, 2t minus r equal to mass into acceleration. So now look once again, t total force 2t and total opposite force is this and this, 2t minus mu2 into r2 minus r equal to mass into acceleration. Now so 2t minus mu2 mg minus mu2 into t, now t plus mu r1, so what is this, t plus mu1 r, t plus mu r, from this equation t plus mu1 r equal to mg minus 2ma, we can put this. So t plus mu1, this in the place t plus mu1 we put here. So 2t minus mu2 mg minus mu2 into t plus mu1 r equal to this mg minus 2ma minus r equal to what? R equal to was m into a minus m into a equal to capital M into a, Now also t equal to what? T equal to, from this equation t equal to also mg minus 2ma minus mu1 into r equal to ma, always this, also t equal to this, because we have to find the acceleration. So eliminate t, we have to eliminate t also, so t equal to this, now put here, we get 2 into t equal to mg minus 2ma minus mu1 ma minus mu2 mg minus mu2 small mg plus 2m a mu2 minus ma equal to capital M into a. So from this equation we have eliminate t is present, a is present here, 2mg minus mu2 mg minus mu 2 mg. Okay, this term and this term, and the term related a is m plus minus ma minus 4ma, which is equal to 5ma minus 5ma. So 5 into small m, and here 2 mu 1 m a plus, okay, now this is mu 2 minus 2 m mu 2, these terms will be present. So minus 4ma minus ma minus 5ma, this will this, and this term 2 into this here, and this for this is this. So acceleration A equal to what? 2m minus mu 2g of m plus capital M divided by m plus 5m plus 2m common mu 1 minus mu 2. So acceleration of the block is, so g here present, so take common g from this side, so you get this, or you can take common this. So this is the answer. 2m minus b2 m plus m into g by m. So this is the expression of block mass m. Student, this is the end of the class today. More such type of problems will be discussed in another video. So subscribe my channel. Okay, thank you.